I started thinking about like, okay, who are we serving? What is the customer base that we want or we even anticipate in the future? Who are these people that are going to use the system? Why are they using it? What is the real value? And how do we actually like drill down to that? And over time, I came to the conclusion that the more important thing that blockchains is doing is not to the end users.
Hey everybody, Tanner here with WAGMI Ventures. On today's episode, we have Sreeram Kannan, founder and CEO of EigenLayer. For anyone who's new, this is the WAGMI Ventures podcast, where we do snapshots with interesting founders from across Web3. Check out wagmiventures.io to learn more about the syndicate behind the podcast. But for now, let's get into it with Sreeram at EigenLayer. All right. Hey, everybody. I'm here today with Sreeram Kannan, founder and CEO of EigenLayer. Sreeram, how are you doing today?
Very good. Thank you so much, Tanner. Really excited to be here and talk to the WAGMI Ventures podcast listeners.
Yeah, we're super excited to have you on. You know, we were obviously really excited to get to participate in this latest round, and I'm really thrilled for the chance to kind of just chat here and unpack some of the awesome stuff happening with EigenLayer. So maybe just to start, could you just tell us a little bit about kind of what brought you to, maybe Web3 more generally, and then also kind of launching EigenLayer?
Yeah, my background in peer-to-peer systems goes far back. My PhD and master's around 2006 to 11 were in this space. But I had moved on. Essentially, at the time, I was working on peer-to-peer wireless systems. I had moved on from that to go work on computational genomics several years after that. And in 2018, early 2018, January or something, I got into blockchains again. Mainly with the thesis that, just like the internet is our information superhighway, blockchains can become the coordination superhighway because, the usual friction to coordination is trust. And if we can make sure that you can actually reliably coordinate and have a certain set of outcomes actually be achieved, that's just such a superpower. So I got very interested in that, as well as all the technical challenges underneath blockchains were fascinating. So I've been super involved and basically switched fields from working on computational genomics into blockchains at that time as an academic. And I ran the University of Washington Blockchain Research Lab, where I used to work on consensus protocols, scaling, all of these things. And while doing it, I came across this pattern that it seems like applications in blockchains are fundamentally bottlenecked by infrastructure. And infrastructure itself is bottlenecked by the requirement that every new infrastructure, which is like a consensus protocol, a bridge, an oracle, a data storage, a data availability, whatever the set of examples are in infrastructure pieces are that are needed, but they are bottlenecked by the ability to bootstrap it. And each of them need to have its own like trust network and so on. And I think that was the problem that I caught my eye quite a bit because, you initially innovate on some infrastructure, like we had a new consensus protocol and then we took it to the Bitcoin community and they're like, oh, this is interesting, but we're not changing anything. And then we go to the Ethereum community and they're like, oh, this is interesting. And maybe there is something we can do in some time. Then we slowly started understanding what the set of constraints around which these decentralized systems are operating. Its governance is very difficult and programmatically minimal. So all of these things essentially like led us down to the pathway of like, how do we enable infrastructure builders in this space to be able to go and express new ideas with very minimal frictions? So that's what led to EigenLayer later on.
Very cool. Okay, so I feel like it's tough to have missed some of the excitement about EigenLayer, what with some recent podcast appearances, and then especially, I think, for some people, the recent Bankless episodes. But for those who've kind of somehow missed it, what is EigenLayer and, what are you guys building over there kind of in its totality right now?
Yeah, the name EigenLayer, Eigen in German for your own, it's a mechanism to create your own layer. So what EigenLayer is it's a mechanism to allow anybody to build their own new things on top of the Ethereum trust network. So imagine, to make it very concrete, let's just say that you're building a data storage protocol like Filecoin. So you have a data storage protocol. The core thing that you want to do is nodes need to download data and store it. And then if the nodes don't do it, they have some kind of penalization mechanism. This is the core of what a data storage protocol would look like. And what EigenLayer does is, and the problem that we see in somebody going and creating a protocol like this is that normally what you need is all of these people who are participating in the protocol need to download and store the certain amount of data, but they also need to kind of buy and stake a new token. That's the usual mechanics by which you get a decentralized trust community to actually validate your protocol. So instead of doing that, what you can do with EigenLayer is you already have this massive amount of decentralized trust in Ethereum. Nodes already stake and commit their Ether into the Ethereum protocol and then promise that they will not violate the covenants of the Ethereum protocol. And what we do with EigenLayer is that we enable Ethereum stakers with the same stake that they're promising to not violate the Ethereum protocol. They can also make additional promises. They can make a promise that they'll not violate this new data storage protocol or other protocols that they're promising to validate on top of EigenLayer. So that's why we call this phenomenon restaking. Maybe it's even more appropriately called programmable staking. When you stake in Ethereum, you're promising that you won't violate the Ethereum protocol. When you stake in Ethereum plus EigenLayer, you're promising that you won't violate the Ethereum protocol and any other protocols that you have opted into. So that's the core. And for somebody building on top of EigenLayer, what it means is when you want to build a new data storage service, let's say you build an off-chain node software that all of these stakers can then download and run, but you also build an on-chain contract. EigenLayer itself is a system of contracts on Ethereum. And when you're building a new service, you build a new service contract which specifies what is the registration conditions, which stakers can opt in to your particular service. Number two, what is the payment conditions? How are you paying these nodes? Maybe you're paying 1 ETH for 1 GB of storage. And then number three, what is the negative incentives or flashing conditions? So if they don't store the data, there may be like an on-chain data, random data challenge. They have to show like some random portions of data. And if they don't show it, then they'll get slashed. But this is the core structure of the EigenLayer system. It's a series of smart contracts on Ethereum that let other people to build new services on top of EigenLayer.
Very cool. Very cool. Okay. So I'm curious to learn more about kind of some of those use cases presently for EigenLayer, where you had a great thread on Twitter, actually, I think back in like November 2022 about use cases, but there's quite a lot of potential ones. And I guess I'm especially curious to hear which use cases have you personally most excited, or where do you see the most promise or potential for significant impact with EigenLayer?
Yeah, so maybe before I go into the specific use cases, I want to present a vision for what the crypto world will look like if we are successful in this project. So, one way to tether the conversation is to look at an analogy from the web development ecosystem. So imagine you're a web developer in 1995 and you're building like a web application. Maybe you're selling books. Now, to do this, you not only need to actually just figure out how to build a website that sells books, you probably need to build your own server that then serves these requests. You need to build your own like login identity stack. You need to build your own payment stack. You need to build your own database stack, which maintains all this information and so on. And you need to do all of these things. Maybe some of these are available as open source tools in 95. Maybe some aren't. But essentially, it's all the web application development. If you were doing anything powerful, you could, of course, go and download a Cosmos SDK and then try to configure everything and then get your own validator set, get your own token of value, and then build your servers on top. Instead, what we envision is the following world. Ethereum is the decentralized trust network underpinning this. So, we can't build all of this just like on AWS because, the core value proposition separating blockchains from anything else is decentralized trust. The decentralized trust is the essential ingredient that makes a blockchain solution a blockchain solution. So how we envision this will play out is that Ethereum is the decentralized trust network. EigenLayer makes it more flexible, more programmable, on top of which other people can come and build new SaaS-like solutions, whether it is an Oracle or a Bridge or a data availability. I'll go into some examples right after. But essentially, the vision that we have is Ethereum is the AWS equivalent for the crypto world. And it was just not flexible or programmable enough. And EigenLayer interfaces make it more programmable. Now you can start building all these SaaS services on top, and then end user applications concatenate these SaaS services to then form the solutions that they want. When you say SaaS, maybe, it rings the wrong way to some crypto people. I think all SaaS is open innovation. It allows for innovators to come up with new ideas that are specialized and solve a problem for all of the field, like a wallet layer, like an authentication layer, like an Oracle layer, like a bridging layer. Each of these are essentially like SaaS-like solutions. Instead of software as a service, maybe it's protocol as a service. Like you're building all these protocols, and then an end user application just concatenates all these protocols and then uses it. Okay, so that is the vision that we have for the crypto space. And Ethereum is the underlying trust layer. You have these SaaS solutions building on top, which then like enable end user applications to be built on top. Okay, so coming to answer your question now, which is like, what are the most important use cases that we're seeing? Part of the cool thing about building a platform for open innovation is you're surprised by what can be built. And I'll give some examples of what we're building and what can be built. The first one that we're building is, if you look at the modular stack, I think other people are talking a lot about modular blockchains. And if you look at the modular stack, people think about like there are maybe three modules that are needed, like consensus, data, availability, and distribution, or whatever. But actually, if you look at the SaaS stack of the web applications, you see there are like thousands of thriving SaaS solutions. And a typical web application uses 15 SaaS solutions under the hood. Okay, that's interesting. So now we think that these three are just like the starting point, just barely scratching the surface of what is needed. That is hundreds or thousands of SaaS solutions that are needed to actually make this economy work properly. Okay, so what are these solutions? I'll start with, for the rollups, the data availability is one major bottleneck, because a rollup basically offloads computation, but you have still inputs and outputs to computation, which is data. And you need to publish that somewhere so that other people can verify the computation or pick up to continue your computation. So the data availability layer is one thing that we're building ourselves, which is a highly scalable data availability layer run by Ethereum stakers. And this is an example where like we're doing an order of magnitude, or several orders of magnitude improvement over what is out there. Instead of tens of kilobytes per second, which is where data availability layers are today, we are able to run it up to 10 megabytes per second. And we think we can scale this, 1000x in the coming 5 years. Okay, so that's one example. Because you're a roll-up, you want data availability. Another example is one of our close partners, Espresso. Espresso is building a decentralized sequencing service. It's an ordering layer for rollups. Rollups have single point sequences, one node, which basically orders transactions. And this is subject to a lot of complexities, co-location, MEV, regulation. Do you really have to trust one node? All of these things. And instead, if you have a decentralized sequencing system running on the Ethereum nodes, I think that's just much more powerful. Okay, so that is another example of a service running on EigenLayer, decentralized sequencing. Number three is bridging. We have a couple of really interesting bridging teams building bridging products for both rollups, like a rollup writing data to another rollup has a huge latency because the rollup has to settle to Ethereum and then move the data to the other rollup. And sometimes settlement times can be very long, like 7 days. And even with things like ZK rollups right now, the settlement times are on the order of several hours. So is there a way to move this data from one rollup to another rollup via a restaked bridging layer? That's something we're seeing. Number four, we're seeing things like super fast confirmations, right? Like when you write data to a rollup, you can't confirm that data without, Ethereum finalizing. And Ethereum finalizing is at least 12 minutes. And 12 minutes is too long for several use cases. So can you have super fast confirmation on top of Ethereum, like running a layer which is able to run confirmations really fast, and then you can then like settle that layer back on Ethereum. And this is, as an example, like Sui and Aptos and other chains are able to have, around 1 second latency latency. So can we actually get that on for rollups? That's something super interesting. So these are all like adjacent to the rollup stack. There are all kinds of other things people are building, trusted execution environment stacks. People are building, oracles. People are building some really off the beaten track things like, can I do AI inference on top of EigenLayer? Can I do SQL queries on top of EigenLayer? Can I do other kinds of things like, proof of decentralization? Can you evaluate whether nodes are decentralized or not? But that cannot be done in a centralized manner. That itself needs to be done in a decentralized manner. We call this proof of location. So proof of location or a protocol, which something like this never has never existed before and is building on top of EigenLayer, called witness chain. We have watchtowers. When you have a rollup, somebody needs to be watching whether the rollups are making the things correctly. If not, they'll trigger alerts and so on. Watchtowers are being built. So another example is, one of the core problems that we see in the space is hacks and exploits. And can you somehow prevent hacks and exploits by having a decentralized network that actually triggers either pauses or other, key transactions when a hack is detected, or even vet every transaction through a decentralized network, which then evaluates the likelihoods of these various risks, and then only vets transactions that pass these risks and then send them on. So there are all these kinds of really interesting things that emerge when you create a platform for open innovation.
Yeah, it's fascinating to hear the breadth and the scope of what's being built. So, one question I had is actually kind of in two parts where it's kind of become a bit of a recurring question here on this podcast where, especially given, mainnet launched June 14th, I guess I'm curious two things. One would be kind of key surprises along this early part of the journey. And the other part would be kind of key challenges and how your team went about solving for those. I know you could probably talk at length about both categories, but and you've really touched on some surprises earlier in what's being built. But, from your vantage point as a founder, surprises and challenges, how do you respond to those categories?
So, when we talk about challenges, I think I have to go way back, which is way before even we started the company. And, I mentioned that first we went to Bitcoin and then to Ethereum and tried to see like who can use some of our technology. So back in 2018, 2019. And we said, okay, like if nobody else wants to use it, why not just build our own blockchain? And this was, so I mean, we looked around and one of the things we saw, there were a lot of white papers, but very few built products. So we decided to flip the script and actually just go and build a project. So we actually, like, instead of going and raising money and writing a white paper or anything, we actually just went ahead and built a really interesting blockchain called Trifecta at that time. And after we built it, we went to go and do a fundraise, and people are like, oh, what does this thing do? And we said, oh, this will basically let you run a blockchain really fast and, 100,000 transactions per second or whatever. And we had a demo showing something like that. And they are like, we don't know how to use the 5 transactions per second that exist in Ethereum. Who's going to use this thing? And, I talked to 40 VCs at that time and got rejections everywhere. But each thing, there was something to learn. And I think at that time, the way we were thinking about it was very technology oriented. It's like, oh, there's a technology problem. Like, can I just go and solve that technology niche? But, you know, technology is there to serve somebody, to serve some values. And without having a clear understanding of what is it in service of, the technology itself is useless. So we wound that up, thankfully, and we didn't go and build a blockchain, even though we have still a working, we just wrote a bunch of academic papers around it. But we came back and then I started thinking about okay, who are we serving? What is the customer base that we want or we even anticipate in the future? Who are these people that are going to use the system? Why are they using it? What is the real value? And how do we actually drill down to that? And over time, I came to the conclusion that the more important thing that blockchains is doing is not to the end users, it is to the developers. essentially having a platform for open innovation means way more people can innovate and concatenate their innovations on a common framework and have a viable working business model on top of it, which then enables a lot of users to then consume the product of this technology, which is then built by concatenation of various different people's innovations. I think this is really my our insight was basically that that's the category of users that then produce products that end users consume. And even things like, for example, censorship resistance, I think in our space, we're used to selling this as a feature to users, saying that, hey, your money you will have the ability to move. I think it's good and it's a good starting point, especially given all the chaos around social networks. But this is nowhere near the full scope of what censorship resistance means. Censorship resistance is also the ability for a developer to know that the set of things that they're building on is stable and will remain to have certain kinds of open APIs that is simply impossible to have a similar guarantee in a non-blockchain world. Okay, so the challenge was that we did not fully understand who the end user is and what the real value proposition is and who we are serving. And then actually identifying of those values enabled us to go and start thinking about how we turbocharge it. We identified that it's not just the application developers that need open innovation. Also, infrastructure developers need open innovation. And in fact, the first version of EigenLayer was not at all based on staking or restaking. It was a completely different concept built on something completely different. And we still called it EigenLayer, and we still understood EigenLayer as something that enables open innovation of other people to build new services on top. So that's, I think, I would say the most interesting thing we learned. But one of the things also personally as a startup founder I learned is the importance of focus. People talk a lot about, oh, you should focus as a startup founder. And when people tell me some things which don't fully fit into my mental model, I usually don't take it or I usually question it. And it
Sure.
took me 6 to 9 months to actually kind of figure out what is being implied by focus. And I think here is my best explanation at it. Startups are like this machines that take linear amount of work and translate them into exponential growth in impact, in usage, in value, whichever dimension you take. Linear amount of work is translated into an exponential output. And when you have, firstly, there are very few exponential games, like very few things where linear amount of work can be translated into exponential output. And so those are very rare. So if you're doing two things, then you should ask yourself, really, do I have two exponential games at hand? That's number one. But suppose you do, like maybe you're very innovative and you came up with two exponential games. That's awesome. But if you have two exponential games, instead of splitting the energy half into two exponential games, so versus focusing on one, actually, if you focus on one, you're modulating the exponent, which means like you're growing at twice, instead of growing at twice the rate, you're growing at 4x the rate, which is way better than two things going at 2x the rate. So, this fundamental paradigm was essentially that there is a clear reason why startup founders need to focus, because startups are exponential games. And in an exponential games, it makes sense to allocate all energy into one thing. And, so this drove a lot of principles for us, which is when we're doing something, we have to understand how it is working through this engine of exponential games, like where linear work will translate into exponential output. It doesn't have to be exponential value created for us. It can be just exponential impact. All of these things, I think, having sharp models on what we're trying to achieve and how do we drive internal processes which can actually achieve it is one of the most interesting things. The other challenge I would say that I faced and handled was, my own expertise was rather narrow. Like I'm a researcher and I'm an academic. How do we build a team which which needs to have so many other kinds of skills? How do you build a team where like people from organizational expertise, like who's the person leading the executional excellence, who's the person leading business development, who's the person leading our legal and policy side? Who's the person who's going to drive our engineering to perfection? Like all of these things, I think it's very difficult as a startup founder to navigate. And I think there's a bunch of learning around like how to build a really strong team, but in a coherent manner. I've been very lucky to have a super strong team all around in research and development and business development. So very excited to bring together and grow this team even further. But I think that is one of the chief challenges of being a startup founder or a project founder is how do you attract people with this vision? But it cannot just be a vision which is far out. There should be concrete steps that we can take today, which will lead us closer to this vision. That's what draws more people in, and then they start building towards the same goals.
Love it. I love all of that, especially the perspective on focus and how that, some of the why behind that from your perspective is really, really interesting. So, maybe just a couple last questions here, where another question that's kind of become a recurring one on this podcast is just, if I were to put to you, the future of crypto is blank, how would you fill in the blank?
That's such an interesting question. The future of crypto is to be the coordination superhighway. I think that's how I'd complete it, because crypto to me is coordination technology. It's the ability to coordinate. Even if you think about something as simple as Bitcoin, how do you know that there is 21 million Bitcoin? Because we have all agreed that this is the Bitcoin code and software. And now that we've agreed on top of it, agreed on that, we are then able to transact. When I get one Bitcoin, I know that I've gotten 1/21 millionth of the total supply of Bitcoins. And this is, and you can just like start looking at everything happening in crypto through this lens. But basically, that's our view. The future of crypto is to be the coordination superhighway for us humans and maybe even AI.
Love it. Sreeram, what is your team working on right now? And what's the best way for people to follow along on the journey?
Yeah, thanks, Shannon. The team is right now, our product roadmap is, since we have a complex multi-sided marketplace, we have, on the one side, we have stakers, the other side, we have node operators, and the third side, we have services building on top. What we're doing right now is building the marketplace out in phases in public. So we've done the first phase, which is stakers can participate in the EigenLayer ecosystem. We are a test net, and then now we are on mainnet, where basically you can stake. And the staking has two parts, native staking or liquid staking. So you can take a liquid staking token and deposit it into the EigenLayer contracts, or you can create your own contract inside the EigenLayer system called an EigenPod and pass your withdrawal credentials through this EigenPod. So you go in Ethereum, stake, and then set the withdrawal credentials to the EigenPod. In the EigenPod, set the withdrawal credential to your own hardware wallet or whatever. So this essentially allows people to participate in the EigenLayer ecosystem. So that's phase one. But phase one is really like just getting geared up for phase two and phase three. And phase two is basically we have delegation and node operators. So you delegate, stake to node operators, which could be yourself. We don't have a permission delegation system. We have permissionless delegation system. You can figure out who you want to delegate to, what incentives they may have. And then and they may be validating one service at that time. And then finally, the third phase is all kinds of new services launching on EigenLayer. So that's the three phases, and we're continuing to build this ecosystem. We're always looking for people who are aligned with this vision and want to contribute in any of these different aspects, of the team. So the best way to contact us is on Twitter, on the EigenLayer Twitter handle. There is also a forum for builders and researchers, forum.eigenlayer.xyz, where you can write new ideas about what to do with EigenLayer and downstream of EigenLayer. So yeah, looking forward to engage closer with the community as we go on through these various steps.
Love it. Sreeram, thank you so much for the time. This was, I think, will go down as one of the more fascinating conversations on the podcast. And I'm really grateful for you taking the time out today to chat. So I hope your week kicks off great here. And thank you again so much.
Thank you so much, Tanner. Really, really enjoyed this conversation, and yeah, excited to be part of the WAGMI family.
Perfect. All right. Take care.